بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we are going to start a new lecture about generic collections, and also this is called Java Collection Framework. So as you know, so we can use arrays in order to store data, right, in a sequence, okay, or to store elements. So we have seen different type of structures for storing elements like arrays and also ArrayList. But in Java, there are several ways or several what we call collections on how to store elements. And this is what we are going to introduce and present during this lecture. So Java Collections Framework, it's let's say a collection of data structures that provide you different alternatives for storing data. Okay, they are pre-built data structures. So what is data structure? تراكيب البيانات, like ArrayList. Okay, and this is why we call them a collection, because we can store a collection of related data together, like an ArrayList, for example. An ArrayList, it's a collection. Okay, it allows you, for example, you can have an ArrayList of student objects. So this is a collection of student objects. You can have an array list of integers. Okay, you can have an array list of doubles. So this array list is also a type of collection, but there are also others, okay, or other type of collections that allows you to store elements inside of them. So as I mentioned, the collection is a data structure, and actually it is a class or an object that can hold reference to other objects, and they are defined in the package java.util, like the array list as well. So these are the collections that we are going to introduce. Okay, so far I think the only thing that you know is the array list, right? Okay, this is the only structure that you know so far. But as you can see, there are so many structures that we are going to discover. Okay, first of all, there is inheritance hierarchy, okay, between these different data structures. So here on the top, let's say the interface or the super interface or the super class, this is an interface collection, okay, is defined as a generic interface for all the different type of collections, and it contains several methods like the method add. Okay, so we can add element to any collection. We can remove element from any collection. So add and remove are examples of methods that are defined in the interface collection. And you know that in the interface, it's only composed of abstract methods. So just declaration of methods. So this interface is extended by two other interfaces. Okay, the first interface is called list, and you remember that we have used list in a couple of cases. Okay, and the other interface is set. So what's the difference between list and set? It's very simple. So list here, it can allow to have duplicate elements. For example, you can have an array list of integers. You can store duplicate elements into this array list. For example, you can have 1, 2, 3, 1 again. Okay, so you can store the same element more than once into a list. This is accepted. However, for the set, it cannot store duplicate elements. For example, if you want to add an existing element into the set, is not going to be added. Okay, you have only elements that are unique in the set. They cannot repeat more than once. So this is the difference between list and set. Okay, list, it can have duplicate elements, and set cannot have duplicate elements. This is basically the difference between both. And then this interface, the interface list, is implemented by two main classes. There are more, but we are going only to present two of them. The array list that you already know, Okay, and this is why sometimes we have written list, for example, of integer equal new array list of integer. It's because list is an interface, okay, for array list. And also another class, linked list, we are going to discover in this lecture, and we will see the difference between array list and linked list. Okay, by the way, okay, in terms of usage, they are exactly the same. But how they are constructed internally, they are completely different. Okay, for us, we're not going to see too much differences because, for example, I can use the same methods for array list and linked list with some differences, of course. But later on in the data structure course that you will have next, which is CS 210, you're going to learn how to construct and how to build these data structures. So in the course CS 102, you're going to learn how to use them. Okay? For example, you have already used ArrayList. You know what are the different methods available to add elements, to get elements, to remove elements, to get the size of the list, and so on. But in CS 210, you're going to learn how to build these data structures, how to construct them. And this is just to see the relation between CS 210 and CS 102 that you're having now. Okay, so for the set, it's implemented by two classes, okay, hash set and the tree set. And of course, as you already know, that set does not allow duplicate elements, so same for hash set and tree set. And here you will see the difference. So let's say that tree set is a sorted set. We're going to have all elements sorted out. For example, if you have a tree set of integer values, they are going to be arranged according to their order. Minimal hash set, it's not going to be it's going to be organized in any order. This is one of the differences between hash set and tree set, and you will see like this later on. So here for tree set, you can store, when you store elements, they are going to be arranged according to their order. So what is the, in this case, the condition that we should have on the class in the tree set? How the class must be? If I want to use a tree set of students, for example. So students will be arranged according to their order. So what is the condition for a student? It must be comparable, of course. Okay? Because if you want to arrange them according to certain order, this order must be defined. صح ولا لا? Okay? For example, if you make a tree set of integer values, okay, integer, we know how to organize them from smallest value to the biggest value. But for example, if you have an array list of employees, okay, how to organize them? We must define a comparable interface for that. So tree set, it can store elements that are comparable. Okay, so this is now an overview about the different collections that we are going to present in this lecture. And on the other side here, we're going to have, or we will present map. And map here, it's another type of structure that will store elements according to a key and value. So we will have two information for the map. For all these collections, you have like one-dimensional array, okay, only one row, where you store elements, okay, whatever you allow duplicate or you don't allow duplicate here. So here it's like you have two-dimensional array. One column is for the key, and the other column is for the value. Okay, so this is what we call map, and also it's decomposed into two different maps, hash map and tree map, and we will see the difference later on. Okay. So as you already know, these different collections, they usually store elements or store objects. We cannot have an array list of int or of double as primitive type. We should have them as wrapper classes. Already know that. Okay, so this was just an introduction about the concept, and let's go now I'm going to create another package. GCF 0.6 here. Okay.
Is this type of generic or another tool? It's completed of generic class or another tool?
This is a new topic, but later on, because some of the quizzes they contain both generic classes and GCF, so this is why I'm introducing GCF before making practicing on generic classes. Okay. So I'm going to introduce. Let me increase a little bit the size here. Okay. Okay, so now if we want to declare, I'm going to declare different structures. So list, now we know what is list. Okay, it's the interface for either array list or linked list. Okay, let's say I'm going to create, so a list of, I can create a list of integer values. Okay, or int list equal new array list of integer. So in the same way, of course, I have to import them. Okay, and you can see they are in java.util. Now here array list and list. So in the same way, I can also do integer. Let's say linked list. I'm going to call it int array list, and this one is int linked list equal new linked list of integer. Okay, so I can add elements, as you already know. I can add elements here. Okay, int list.add for int list.add -1, int list.add 3. And the same thing I can also do for the linked list. Okay, so you can see in terms of usage, it's the same. I can also add elements, and I can print the elements of both. Okay, so this is int array list here, and the same thing I will do for int linked list. Okay, so in terms of usage, linked list and array list are the same. I'm going to show you the difference now between both in terms of structure. Okay, so if I define set now, set of integer values, let's say int 3 set equal new 3 set, or let's start with hash set of integer. Okay, and this is now hash for hash set, and I will do also 143 set. So this is hash set, and this is 3 set. So I will show you difference now between both. Okay, I can also add all the elements in the same way. I can do the same here, dot add, okay, but there is another way that we can do. We can have add all. So what does it do add all? I can put a collection here, and it's going to add all the elements of that collection. For example, I will add all the elements of linked list. Okay, I will do that for hash set and for tree set. And by the way, I can do also for the array list. For the linked list, I think it has also the add all dot add. It has the add all also. Okay, I can do the following. Voila. So I will add some more duplicate elements here. Let's add some duplicate elements. I will repeat for. Let's put more elements. -1. So -1 is repeated, 3 is repeated, and 4 is repeated. And all these elements were added to the linked list, to the hash set, and to the tree set. So now I'm going to print hash set. Let's print again the linked list. So linked list and array list, they store duplicate elements. You see? Okay. Now I'm going to print hash set int hash set, and let's see what happens. So it removed the duplicates. Voila. And by the way, okay, now you can see that hash set has kind of stored into according to their order, but this is not the rule. Okay. This is only true forever for tree set, as you are going to see. Now, if I'm going to print tree set, okay, so same thing. You see now, all the duplicated elements were removed automatically from the set. Okay, now even if you want to do, look, let's say I'm going to add 4 again. Look now, I'm going to add 4 for all the different elements. For the linked list, for the hash set, and for the tree set. Okay, S out, adding 4 to all collections. And now let's print them again to see what's going to happen. So adding 4 was added to linked list and array list at the end, but it was not added to hash set. So even if you add an element to a set, whatever it is, hash set or tree set, is not going to be added if it already exists, because it will not allow duplicate elements. So one of the good things that you can use, if you want to remove all duplicates from a list, you can convert it to a set. Okay? And all the elements will be automatically removed. So instead of doing this manually using a for loop and checking the values one by one and so on, you can just put a list into a set, and then you're going to have all the duplicates elements automatically removed from the list. Voila. So now this is to illustrate the difference between set and list. Is it clear? Okay. Of course, now if we go to the Java documentation of all of this, Java collection, Java list, and Java set. Let's go to these interfaces. Okay, look here. These are the collections. So for all collections, whatever they are, list or set, you have the method add, you have the method add all, you have the method clear. Clear, it removes all the elements from the collection. For example, if I do here int ArrayList dot clear and I print again, okay, all of this, so it removed all the elements. Okay, so clear here, it removes all the elements from this collection. Contains, it check whether an element or a collection contains a specified element. We have used contain in some examples. Contain all, return true if the collection contains all of the elements in the specified collection. This to test the equality. The hash code, to return the hash code value for this collection. Checking whether the collection is empty. We will see about the iterator later on. You can remove an object. Okay, you have remove all the collection's element that are also contained in the specified collection, and size to return the number of elements in the collection. You have to array, returns an array containing all of the elements in this collection. So you can convert a collection to an array. Like, for example, I want to convert this set into an array. So I can do an array of integer int array equal int hash set dot to array. Okay, what's the problem here? Okay, object here, an array of object. Okay, so to array, it allows to convert an element of the collection. And to array returns an array containing all of the elements in this collection, the runtime type. Okay, this is using generic type T. So all of these methods are common to any kind of collection, whatever it is, list or set. Okay, for example, here I can do to array either for the set or also for the linked list. Okay, it's possible. We have also methods for the interfaced list. Okay. Several of them are inherited from collection, like add. So here in list we have the same method as in collection. So this is inherited. But here in list you have add at a certain index, which is not in the collection. Okay, add int index element e. For example, here I can do int ArrayList dot add. For example, add an index 3, the value 10. Voila. And I can do the same also for int linked list, because both of them are lists. Okay, so they implement these methods. Add at index 2 the value of 19. Okay, I can now check their content. What's the problem here? Element E. Range check for add. Yes, because I have cleared because I have cleared, so I cannot add. So I'm going to remove clear here. Okay, look now. So 10 was added at index 2. واضح? And here 19 was also added at index 2. 0, 1, 2. We start from 0, the index, and then 1, and then 2. Okay, so this method is only specific for the lists. It cannot be for the set. Now, for example, if I look at the set, I can do that. Now, if, for example, if you want to come here, set, which one? If you want to make dot add, for example, at index 2, any kind of value, 10, it will not accept because it's not defined for the set. Because the set, actually, you cannot tell in which index because it's going to be sorted out. Yes, automatically. So we can't do that. واضح الفرق? Okay. And if you see here, we don't even have a method for add index like here in list. So this is a method specific for the list. You have add all, and here you have add all starting from a certain index. Insert of all of the elements in the specified collection into this list at the specified position. Okay, and this you don't have for the set. Okay, so you can see the set, it's almost the same methods are as in collection, nothing special. But for the list, we have some additional methods. Yes?
So if I did a clear, I can't add something to the list?
No, you add because if you do clear, you can add element by element. You can do add. But you cannot say, okay, add at this index. For example, you make clear and add at index 4.
There's no index.
But it's empty, yes, there is no index 4. Okay, so that's the point. And now we have clear, we have contain all equal. Well, okay, we have something interesting here, which is useful for the list, is the method get. We have already used get for the array list. Okay, so we can also use it for the linked list as well, the method get, but it's not available for the set. Now, if you want to try this, okay, let's say third element in int linked list. How to get this? Plus int linked list dot get index 2. This is the third element. واضح? Okay, so now if I check this one, it's going to work. The third element is 19. That's pretty much fine. If you want to do this one, now for example, what is the third element in tree set? You can't get it. We don't have get into the tree set. Okay, so you might wonder now, okay, how can I access the values? That's the question. Okay, I'm going to tell you how. There is a way, okay, on how to go through all the elements and get them one by one, what we call an iterator. We will see it later on. So we don't have get into the set. This is one of the differences now between get and set methods. You have index of, which you don't have in the set, or you want to have the index of an object into the list. For example, now we can do index of, let's say, -1. Okay, in array list or a linked list is the same. So what we can do, array list dot index of -1. What is the index here? Is there anything missing?
Yes, before the int array list.
plus here. Okay, what is the index? 0, 1, 2, 3. Okay, so the index here is going to be 3. واضح? Okay. If I make what is the index of 4? What is the index of 4 here?
1,
We have the duplicate values. Which one is going to be?
first one.
The first one. Okay, so here the index of 4 is going to be 1. If there are duplicates, it's going to return the first occurrence. Okay, now this thing we cannot do it for the set. You cannot say, for example, here, what is in, say, hash set, index of doesn't work. Okay, because it's not defined in the interface set. So here we don't have in the interface set, but you have index of. So is empty is the same. Iterator we're going to talk about. Last index of. If you want to return the last index, for example, of 4, okay, if it is duplicate, we can use this one. Okay, so if I change this by last index of 4, and here dot last index of. So what is the last index here? 9. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
But can I do it for object to get index of single one in ArrayList? Can I do it for object?
Oh, yeah, you can. Now I made on integer, but this thing you can do it on any kind of object, whatever it is. Okay. We have remove. So here remove, you can see that in the collection we have only one remove. That is, we specify the object, and in list you can specify remove with the index and or with the object. And this is now an issue, you know. Okay, so if we have an object like student or employee, it's clear. If you do remove student object, we know that we mean the object. And if I put 1, 2, 3, 4, we mean the index. صح ولا لا? Now the problem here, if we have an integer like this, if I write, let's say, int ArrayList dot remove 2 or 1. What does this mean?
Index
ليش ما هو integer 1? Then I want to remove this one.
we need to put in integer bracket.
Integer? Yeah, so by default it's index. Okay, by default, if I put 1, so what value is going to be removed?
False.
Let's check. So 4 is removed. Because this is the index 1. But if I want to remove this one, so I need to specify that I mean the object. Okay, in this case I can do a casting on 1. So what will be the result now?
Start from 10.
It's going to start from 10. You see the difference now? And this is confusing only in the case of int and integer. If you have double, you don't need to make this kind of casting. Or you have any kind of object, you don't have, because now the compiler is going to distinguish between the object and the index. But in the case of integer, the compiler is not able to distinguish only if you explicitly specify using a casting whether this is an object or an index. واضح؟ Okay. You have also set. If you want to replace an element at the specified position in the list with the specified element. Okay, so for example, I want to replace this value by, instead of 3, for example, 24. So this value is what? 0, 1, 2. That's at index 2. So I can use set at index 2 and replace the value. Okay, so here what we can do, int ArrayList dot set. Let's say at index 2, I want to replace the value by 24. So this value is going to be replaced by 24. If I change this one, okay, you can see this value has changed to 24. Okay. Yes?
Is this different from the add? Because we can just say, even though there is a value at 2, we can kind of still say
Add is going to add. Look, now the number of elements did not change. Okay, the number of elements remains the same, but this value were 3 and changed to 24. Add is going to add and keep the same elements. واضح? Okay, we have size. Okay, we have sublist. Okay, also you can return a view of the portion of this list between the specified from index and the to index exclusive. Okay, for example, you want the sublist between, let's say, 24 and 5. Okay, how to write this? Okay, I want the sublist between index 2 and, say, 5 or 6. So look now. This is possible if I do int ArrayList dot sublist. So index 2, index 6. So 2 is inclusive. What does it mean inclusive? It's going to, for example, 0, 1, 2. This value is going to be included into the sublist. The last index is exclusive. It means it's not going to be included. So yeah, we're going to 0, this is 2, 3, 4, 5, 6 is not included. So the sublist will be only these 4 values. Okay, so let me execute. Look now, from index 2 to 6, I had 24, 3, 4, and 5. So in principle, -1 is the index 6, but was not included because it is exclusive. And this is what we mean here by exclusive. واضح؟ Okay? And finally, we have to array. It was already introduced. So now in this lecture, we have introduced the main different types of collections. Okay, so now I think you understand better a little bit this diagram. Okay, we have the interface collection, that is the super interface. It is extended by 2 interfaces, اللي هما list and set. Okay, and list and set is implemented by the classes. So list is implemented by ArrayList and linked list, and set is implemented by the classes hashSet and treeSet. So the difference between list and set is that list allow duplicate values and set does not allow duplicate values. For ArrayList and linked list, they use the same methods. Okay, they look similar, but internally they are different. Tomorrow, I'm going to explain you with more details the difference between array list and linked list. But today, we have presented the difference between the list and the set, mostly. Okay, they have different type of methods. Okay, so list, it has more methods, for example, getting values, okay, setting the values, getting the index of a value of an object, and so on, things that are not in set. Set, you typically, it has only the methods defined in collections. It doesn't have additional methods like the list do. واضح? So this was now introduction of the different type of collections, and tomorrow we will talk more about the details and the difference between array list and linked list.